Previously, we discussed a little bit how you would formulate the problem setting for building an Instagram feed ranking system. How do you plan to deploy this into the product, and how would you continue to monitor the model in real time? Thanks so much for returning back here, Vikram, for part two of our Instagram feed ranking question. Would you quickly introduce yourself again for our viewers?
Yeah, very quickly, my most recent experience has been as a senior machine learning engineer at Meta, working on ranking and recommendation systems.
Awesome. Yeah, you have exactly the background for this question. So, as I mentioned previously, we discussed a little bit how you would formulate the problem setting for building an Instagram feed ranking system. And we talked about how we would train and evaluate the model offline. So, what I'd like to hear from you today is how do you plan to deploy this into the product, and how would you continue to monitor the model in real time?
Right, great questions. First off, just to recap where we were last, where we finished off, and then that'll lead into how we deploy and some of the architectures around that. I'm going to quickly share my whimsical. Great. What we discussed last time was building a two-tower network that allows us to learn the embeddings for viewers and post items into the same low dimensional, we call it d-dimensional space, that allows us to now use these representations to immediately or rather quickly generate the candidates for ranking and recommendation. So again, just as a recap, there are three stages in this pipeline. There's a candidate generation stage, there is a ranking stage, and then finally there's a post-processing stage. In the candidate generation stage, we want to cut down from millions of possible post items to a few thousand. Typically, 1,000 or so should suffice. Then, in the ranking stage, we sort them out in order of which are the most relevant items, and then we finally do a post processing for fairness and freshness and items of that nature. So that's the pipeline. So the essential task then becomes how do we learn this embedding and this d-dimensional embedding for the users and the post items, and that's where we kind of stop. Now the question becomes, how do we deploy this, and how do we continually update it and monitor it and so on. I'm going to quickly draw out a sketch of a, a few abstractions that allow us to think through that clearly in real life, and we'll talk through that once I quickly sketch it out. Okay. Are you able to see my screen, Angie?
Yes, I can see it.
Great. Okay. I'm going to quickly draw things out here, and what I'm drawing out is essentially an app that uh, that calls up the service during serving time, and then um, subsequently is able to use an updated versions of these models. So give me a second here. All right, and let me draw some arrows or lines rather. All right, so these are the abstractions that I see, and that allows us to talk through this. And these abstractions come from, these are research-based abstractions. This is typically followed by several organizations in how they deploy machine learning models and how they continually upgrade them, monitor them, and so on. But the research-based findings that support this, not rather support, that make this valuable, is that a structure like this allows an abstraction structure like this allows us to learn on a continued basis. So here, what I'm showing is an app which reaches out to the explore phase of this abstraction. In the explore phase, what we essentially do is we serve the model. That is, we the app sends out a request to this endpoint and says, I have this user, Vikram, on the platform right now. What are the recommended post items for this particular user? So this arrow right here embeds a lot of things in it, which is a lot of context about who the user is, what time of day it is, and so on and so forth. And as a background to this entire diagram would be a box like feature generator. What that is intended, what I'm intending to show with that is that the feature generator makes it available for the features to be available at the time of the request. So the app makes a request to the explore phase, and the feature generator at the time of that call makes available all the features that of the particular user uh, available for serving. So now the explore phase, which is essentially a machine learning model, is able to serve back to the app as a response. Where's the arrow? Is that the arrow? No, I think this is the arrow I was using. Okay. Serves back to the app the post items that are relevant to this particular user, right? So that's the interaction that happens. And this, you would think, would be a final deployed model that we're using within the explore phase. And the reason it's called explore is it's not simply that we are getting the most best or highly recommended items for this user alone. There is some nature of exploratory uh, serving of some of the content that the user may not typically would have seen. And that allows that explore that outside the box of content, outside the box of what is typically would be seen by the user, allows for this machinery to learn possibly other areas of interest for this user. The Explore gets its data, its machine learning model from deploy, which contains all the machine learning models that we have accrued over time. And another item that I want to talk about very quickly before I pause and see whether you have any more questions and so on would be um, the log phase. So in the log phase, what typically happens is, and as we spoke about previously, um, all the interactions that the user have with the content that we have sent them back through the recommended items happen subsequent to the user having seen them. So this is a delayed action that happens. I like a post, I dislike a post, I comment on a post, and so on. So the logging happens subsequent to it at it could be anywhere from a day to a week to a few hours to a few seconds. So there is a nuanced choreography that is required to make sure that all the features X and the predictions and the actions that were recommended here by the explore phase are captured here in the log. And I'm notating this using an R here to notate that there's a reward that's associated with that log. Very quickly, what happens here is now we tie together the X and the A and the P and the R that gives us a tuple of the entire coherent tuple of the entire interaction that has happened with the user interacting with the content that we had previously recommended to them. And based on that one tuple that comes in, we could possibly learn again, meaning this is your relearning or update of data of a model. And this would what we would typically call as online learning, because a single instance of a user interaction has now allowed for us to gather some more signals as to how these particular content that we have shown them has caused the user to behave in one way or the other. And that's the online learning. And one could also conceivably see this here, there is a offline learning that happens here, and you may draw it out like this. This is akin to more of the traditional batch learning that we speak of typically, in which there's a collected set of data, maybe a week's worth of data, maybe a month long worth of data, and then we do a refresh of the model from scratch, maybe. The online learning that I'm showing you here is just incremental, individual user based, user action based relearning of the model. I'm going to stop here and see whether you have any questions or anything you want to talk about here.
Yeah, okay. So to recap then, A is like the action. So that would be the actions the user is taking, like which post they engage with.
No, this is the action I should write it down. This is the action that we recommend. In the sense, this would be the post
Oh,
item.
the post that would be presented to the
Perfect.
user. Okay,
Exactly.
and P is the probability of each. Okay,
Probability.
so then reward actually reflects whether or not the user engages with it, right?
Exactly.
Hmm.
And X is the feature. And this,
Okay.
yeah, this abstraction like this allows for this is only required. It is only required because it makes an online learning possible.
Right. Yeah. Okay. That makes a lot of sense. And then you had also mentioned deploy represents like the models plural. Are you deploying multiple models at once or just the most recent one?
Yeah, we typically want to deploy the most recent model, but conceivably we have a model store for variety of reasons. One is, we may have deployed for whatever reason a model that is catastrophically wrong. Uh,
Hmm.
either it has been corrupted, either it has not performed well for whatever reason, or it is unfortunately not performing well right now. And then we may want to switch back to an earlier model. So we typically do want to have a repository of models, including a few flavors from historical, from the past.
Okay. Got it. Thanks. All right. So I think this is a great high level overview. I'm eager to hear a little bit more about the details of each component.
Yep. So let me quickly see here. All right. Where is the user sitting in this entire interaction, right? So that would be a good thing to look at, or good item to point out. Uh, and the users are here. Right? They interact uh, with the app. Right? In the act of interacting with the app, they pass on their context to the app. The app captures that and reaches out to the explore phase in which a machine learning model actually sends back the post items. And as we previously mentioned, the feature generator captures the fact that the features of the particular user and any ambient features, the environmental features, are also made available in this call to the machine learning model,
Can you
right?
give some example of what ambient features would be?
Yeah, for an ambient feature would be, say, the day of the week, as an example, right?
Mhm.
The current time, um, uh, whether that particular day happens to be a holiday, uh, the anything that is typically not captured within the specific user itself could be considered an ambient feature.
Okay, sounds good. Yeah, it sounds like it's like neither really user or content specific.
Exactly, and it will be, you can think of it as environmental features if you want to call it that.
Okay, yeah. Hmm.
So those are all made available, and the explore phase gives us back the post items. Now, we have already talked about how the post items are generated, and as a, maybe I'll just call this our ELLD explore workspace. I'm going to quickly draw something out that explains to us in a quick short detail how we find the approximate nearest neighbors. We kept on mentioning this last time around as well, and just this is just for your audience so that we recognize how the nearest neighbors of a user are calculated. And I'll try to quickly draw this out using this is a KD tree or K dimensional tree. Let me get this here, and that'll tie back into the question that you asked me. Um, and then I'm going to write it off here. This is x1, then this is x2, this is x2 as well. And I'm going to write out some numbers here, and I'll explain to you what these are. Now, that's not the kind of line I wanted. How do I delete that? Is that so? This should be reminiscent of a binary tree for for most people, right? Uh, what I'm showing here is how is it that we the system computes the approximate nearest neighbor, right? There are several ways to do that. One quick and rather easy way to recognize this or understand this is to use a k-dimensional tree. Let's say there are two features, x1 and x2, right? In reality, the number of features could be in the hundreds or thousands, right? So we are notating in these circles the center points of these centroids of these k-dimensional tree that the data gets split into, right? So anyone who has a value of feature of x1 less than or equal 2.3 goes down the left hand side, okay, and anything that
Mhm.
is higher goes on the right hand side. So if I wanted to notate it not like that, something like here, this should be less than or equal 2.3 in that feature, for that feature x1. This is greater than 2.3. And the second layer is for feature x2. So if I take now a vector for me, let's say I am the viewer and I want to find nearest post items for me, and let's say I am 3.7 and negative 1.8. And of course, there will be many, many more, hundreds more. This is me. The user is here. What I do is essentially walk down this tree and find users in the final cell that I am in, or I am that I would be located in, and pick all the posts in that cell, right? And then sort them by the nearest shortest distance, and that gives me approximate nearest neighbors. So in this case, I have 3.7 and negative 1.8. My x1 feature is 3.7. My x2 feature is negative 1.8. So I go into the first root node. Okay, I'm on the right side of 2.3. I go into this node. I'm a negative 1.8. I end up here, meaning like right here. This is where I am, right? And
Mhm.
so we would be picking all the post items that belong in this cell as well. And then I would be calculating the nearest neighbors of that, nearest neighbors from that. So, like we said, we may pick 1,000. There will be literally millions in this particular cell, but we just pick the top 1,000. Okay, and you can we could narrow the number down by having a deeper and deeper tree. But this is just to drive home the point that we can do an approximate nearest neighbor using something known as a k-dimensional tree. And this is the technique. This is one of the techniques that we would use for. Let's see, how do I go there? That we would use to figure out who the post items or what the post items are that we need to return to the app when we sent out a request for this particular user.
Okay, and so to kind of summarize, you're using the KD tree basically to just narrow down the number of users that you would search for that are similar, right? And then once you narrow that down to like a particular node in the tree, you mentioned like finding the ones that are closest. Is that like Euclidean distance of like the feature vector?
Yep. So you can use a variety of metrics, Euclidean distance being one. You could use a cosine distance. You could use a dot product. You could use Chebyshev distance and Manhattan distance, and lots of other metrics depending on what a particular flavor of distance we want to use. And the short answer is yes. That's exactly what we would do. We would pick the post items. Remember, me as a user and a post item, they all belong in the same d-dimensional space. So we could use the same KD tree to figure out what are the post items that are closest to me based on this logic. And there,
Gotcha. Okay.
yeah, and there are several nuances and variances to this as well. And I'm just picking KD tree because it's easy to explain and narrate during an interview, right? So
Okay, yeah. And I'm glad that you explained one of these methods for doing approximate nearest neighbor search, since it's definitely not a trivial problem.
yes, it's definitely not a trivia problem. You and
Mm.
the reason we want to use something like a KD tree is because we do not want to have a nearest neighbor across the hundreds of millions of posts. And just by the act of walking down the tree, we have reduced the number substantially.
Right.
We
Mhm.
would be looking at only a few thousands or few hundreds of thousands at worst. Okay.
Okay,
Uh,
perfect.
Yep. And then once we have narrated, once we have supplied back to the app who the post items or what the post items are, we wait essentially, which is what the logging phase is for. At the logging phase, we are able to, again, the app would send back that the person has liked post number one. and that is logged, and that is made available within in a log database or a log queue and so on and so forth. Whatever kind of infrastructure we would choose to store them in and queue them up in. Typically, they're queued up in they're put in queues because there are several um, consumers for these, and not just reside in a database. These log messages, and then uh, and the queue, of course, can supply it to the relearning or the online learning mechanism. Uh, the queue could also supply it to a storage mechanism, right? So you would store it here. You could also send it out to the online learning mechanism. Further, this queue is extremely important. This queue, meaning this signal, is also extremely important because it's an action and activity by a user. This could also be used to feed into is the second point of your question, or the second item that you wanted us to talk about in the question, which was how would you monitor? So this could feed into a monitoring service, uh, and the way and the monitoring services, they're not just looking for the raw signals. They could be looking at aggregates. So, for example, complex event processing, things of that nature, where we're looking to see on aggregate how in the last 15 minutes or last 30 minutes or an hour, how has our uh, number of clicks by users varied. So, for example, historically, if we have had a click rate of, say, 30%, how has that been in the last 15 minutes? How has it been in the last hour and the last day, and so on and so forth? So, things like that are captured in our monitoring system. And those could be
Mhm.
triggers. Those could be causing alarms or triggers to operators like machine learning engineers who are in the ops team who are watching things of this nature. Let's say traditionally our click rate has been zero point 0.3, and for whatever reason, let's say our click rate has gone down to like much lower than, like, say, 0.01. So that should be a cautionary signal for our machine learning engineers, I mean ops team, and those could be driven off of this message queue, which is feeding into a complex event processing machinery, like a monitoring machinery. Uh, yeah, I'm going to stop there on that particular item. Did you have any questions, or did you have any thoughts?
Yeah, that makes a lot of sense. I like that you covered that monitoring process as well, since that does have to happen in real time. I'm curious, I guess like part of the monitoring process is like anomaly detection. I'm curious, like the example you mentioned before sounds like it would be kind of maybe just based off of like a moving average and whether there's a significant deviation from that. Are there other like ways that you can do that kind of anomaly detection, just like at a high level?
Yeah, no. There are other ways of doing anomaly detection. One could conceivably build out a machine learning model itself
Hmm.
to detect anomalies, right? In
Hmm.
fact, if you look at the space of security, as in, like, cybersecurity, uh, there are machinery that are being built, machine learning models that are being built to specifically tap into anomalies. The
Hmm.
way they do that is, using various techniques. One of them being Gaussian mixture models, and so on and so forth. Essentially, figuring out if this data point that I have just encountered so far off the mean that it should cause an alarm, right? So yes, there are machine learning models one can think of. There's also heuristics and moving averages and, standard deviations, etc., as we previously spoke of, that can also be used for alarms.
Okay, yeah, that's really interesting. It seems like there's like a whole other realm of work that can be discussed there. Yeah, but continue.
Yep. So that would feed into our monitoring and alarm system, and the online learning system that we briefly spoke about previously is essentially this. Now we are able to gather this one record and somehow update our machinery, right? Which means I can now relearn or update my models. This is a live model that we are updating, right? So we have to be a little bit cautious of how we update this live model. The typical way to do that is to weigh down the learning, because it's only one record or one user interaction. So weigh down the learning by reducing the learning rate, and then update the weight parameters based on what we have received. Okay. And
Mhm.
then, of course, we gather all these into a repository so that we can also do offline learning once a week or once every couple of weeks and so on. And that's the online learning phase. And then at some point we choose to have a new model deployed. Remember, the online learning model is a real model that's in real life. That is not a That's a model that was previously batch learned or offline learned, and we are updating it slowly at a trickling pace, at the rate at which users interact with the post items that we show them.
Mhm.
But in addition to that, we can also have a offline learning that happens once a week or so. And then if we see a substantial improvement in the A/B tests on these offline learned models, we can deploy it by hand, right? Typically, when we push out models into production systems that are done, there's always a gating that is done by an individual or a team that looks at the outcomes rather than automatically being pushed out. And then once we push a model out to the model store, we want to archive the previous versions of the models with inappropriate annotations and so on. That's what we are representing here with the deploy box. Yeah, that's about that. That about summarizes what I wanted to touch upon here. Are there any areas you want me to expand on? Any questions?
Yeah, so I'm curious about, you had mentioned that for the weekly updates of the model, you would probably use like A/B tests to try to identify, okay, what should we deploy this new model or just keep the existing one that we have? So that sounds like it's on like a weekly basis. I'm curious how you might assess like the long-term impacts of model changes, because perhaps there's some change that doesn't really show up in your metrics until like over a longer period of time.
Yes, that's a that's a very important point. Yes, uh, so I want to quickly touch upon this A/B test portion of this model update, and then we'll get to the long term behaviors and long term metrics maybe.
Mhm.
So the A/B test is here specifically because remember when we started off with our entire enterprise, which is of designing machine learning model, we recognize that there is a distinct difference between the ML objective, the ML objective being increase the engagement of this particular viewer on our platform, as opposed to the business objective being an aggregate that says, hey, let's improve the session time that our users, our viewers spend on our app, for example, or the number of clicks that they engender, or maybe their DAO, which is daily active user, right? They may not directly be related. There may not be a direct line of sight between the aggregate metric and the individual action, but typically there is, or we assume there is. And that's why it's important to have an A/B test as a gating uh, before we push models into production. That's one point. The second point to really understand and consider would be the A/B tests also allow us an opportunity to look at some of the possible negative effects of a newer model. And those would be safeguard metrics that we typically are not embedding into the machine learning model itself. So, for example, in the case of post items, the negative might be something along the lines of number of blocks of content creators, number of reports of content creators. So if our recommendations somehow improve the click, but at the same time also increase the number of reports or blocks, that might be a negative sign. It might be possible that we are showing people content that they viscerally react to, but also they perhaps do not like, things of that nature. So that's why the A/B test becomes important and as a gating before we push models into production. Now, if we, in terms of longer term effects or impacts, if we are updating models at a cadence of once a week, you're right, we have no opportunity to see longer term behavior changes specifically for a particular model in real life. So what we typically want to do is when we deploy models to production, we do not deploy it to everyone. We can segment people into different categories. Some of the users would actually see the previous version or two versions previous to what we have currently. And that allows us to see whether there are any behaviors or any distinctly different uh, s- um, metrics that are caused by these models over time.
Okay.
Does that make sense?
Yeah, that makes sense. So basically you're saying that there's like essentially an arm of the A/B test that is like a long term, like the feature is gated from them. So you have the chance to differentiate the short term versus long term impacts of this model.
Yeah. So I want to maybe partly that's what I meant, but let me draw it out in a box like this, and this
Yeah,
may help
okay.
uh, a little bit explain what I'm trying to say, which is let me draw this out like this, and how do I put this here? Okay, let's say this is production, as in like all the entire users of production. Uh, we can hold off. Oh, I can't type it. No, not there. What I'm attempting to show is segments of users. So this entire block is what we call production, let's say. Uh, V1 are users who see V1 of the model. V2 are the set of users who see V2 version of the model,
Hmm.
uh, and so on and so forth. And it may not be just one or two. In reality, there may be several of them. And in addition to that, we may have like a holdout, and a holdout set of users perhaps see control. Uh, they would not be subject to any of the models from the beginning of the half, for example, right?
Hmm.
Beginning of the year, for example, and they would
Yeah.
always see an older version of the model. So you can always compare V1 against V2, sorry, V1 against holdout, V2 against holdout, and that will allow us to study the long-term behaviors.
Okay, gotcha. All right, thank you so much for that answer. I think this is a great place to pause. I really enjoyed getting to hear this like part two of how we deploy this model in the real world. So I'm curious to hear from you what you thought of this part of the interview. Like, what do you think went well, and what do you think you wish you could have expanded upon or changed?
Hmm. Uh, what do I think went well, and what could have changed? I think just being able to explain these abstractions, or I think is powerful, and I think it gets across through to the interviewer the various phases of the actual infra pieces of deploying and serving a model and so on. So that was a good part. Going into the KD tree was helpful from the side of how do we generate candidates, right? Approximate nearest neighbors. What's a quick and easy way to recognize that? There are other techniques as well. So those two I think are helpful. What could have been better? I think I always feel like, personally for me, that the time that is available on some of these conversations and discussions are much too narrower than what I would like to spend. So maybe it's partly
Mhm.
me, but perhaps some way of preparing the material in such a way that I'm able to deliver it much rapidly would be a possible improvement.
Yeah, it's always hard to do that trade-off between like the high level explanations versus how in-depth you should go into the details. And like we sort of talked about like the approximate nearest neighbor, that's only one component here, and yet that could already be something that you really discuss many, many different aspects of, right? So it is hard to strike that balance. But I agreed on a lot of those points. Like I really appreciated the high level organization here that you gave us kind of this high level overview or big picture of what the different components of your system was before delving into the details. And you covered both the offline and online versions of learning, which I think is particularly important for deployment. Like you don't just train a model once and release it into the wild and like you're done. That's never really the case. And I also really like that you differentiated between like the ML learning objective and the product goals because oftentimes those are really different. The product may have many, many goals that are not directly captured in um, the training objective that you're using. Yeah, and I ended up asking you a question about this too, but I liked hearing about how do you account for shorter term versus longer term metrics. And then one thing I would have been curious to hear a little bit more about is in a real world system, like the data distribution often changes a lot. So, you know, in 2020, we got the COVID pandemic. So probably had a bunch of new content that you'd never like gotten features for, just like revolving around COVID. And so if we have this system that keeps on basically like maximizing upon like the signals that it's receiving, there may be a little bit of a feedback loop there. So when there's like this sudden like new subset of data or like a change in data distribution, do you think your system would have captured that shift in distribution well, or is there something that you might have to do to account for that?
Very good question. The non-stationarity in mathematics, we call it
Yeah,
non-stationary
yeah,
data, right?
exactly. Yeah.
Right. So, and that's exactly what this abstraction that we are discussing here is attempting to address
Hmm.
through this online learning. Non-stationarity of data is a problem in any system that has in real life system of substantial use. In fact, in social media, it's quite often the case that uh, there is non-stationarity of data over periods of time over greater than a month or so. Or if caused by an external event, like you said, like the pandemic or so. So that is what this relearning phase is supposedly uh, addressing, directly
Yeah.
addressing this
Hmm.
non-stationarity that creeps up on incremental use of the system. That's one. uh, the other is if there are drastic changes. So the one item that comes to my mind right off the bat is something along the lines of um, there may be drastic changes that require a manual intervention, and that's
Hmm.
something I have seen specifically used within like products like news media, like MSN and so on. What they have is they have overrides on top of all these machinery that we have built. There are overrides that are made available in order to address drastic scenarios that require a human intervention,
Right.
not just ML learning. So those are the two things that come to my mind. I do not, I don't have anything more to add at this time to that.
Yeah, that makes a lot of sense. And I think it's important for us to touch on the fact that like these ML models rarely operate in isolation in these systems. There's always many more mechanisms built on top. So it was really interesting to hear from you about how we can fit that model within the wider ecosystem of software that we have in these systems. And really a really good integration of like product goals with like machine learning concepts. Yeah, so thank you so much for explaining all of that to us today, Vikram. I thought that was so well explained, and it really had great coverage of a wide variety of aspects to consider when designing such a system. Yeah, so thank you for being here with us, and thanks everybody for watching. Good luck if you have any upcoming interviews. Bye, everyone.